Welcome to another Lightblade Learning Lab. Today I think is going to be another quite interesting session. We're going to be making something today, but it's something that you will probably use a lot once you've seen how simple it is to make and how simple it is to use. Rotary engraving is something that you probably might not be able to afford to do. Thinklaser do manufacture rotary engraving systems. They manufacture two types. They manufacture one which is like a three-jaw chuck system, which is a rotating system just like a chuck jaw on lathe. And they also manufacture a wheel system, which basically is a circumferential drive system. Both results are for producing engraving on things like glasses, bottles, rolling pins, pens, those sorts of round objects where you want to engrave a name or a logo or something like that. Those engraving systems, they're not cheap, several £100s. What I'm going to show you today is a very, very simple idea for making a rotary engraving system. It doesn't involve using a motor or anything like that. There is a saying around that says, genius is a perception of the obvious that nobody else has recognised. I wish that applied to me. Sadly, it doesn't. A guy called Caesar Medina sent me a video of a device that he'd made for himself. Now, brilliant doesn't really describe it, and you'll understand what I mean when you see the final result. I'm envious because I really wish that I had spotted it before myself. But the glory must go to him. So what we're going to do is to take the concept of what he did and modify it to suit this machine. His design would have worked on this machine, but there are some, I consider, some potential weaknesses in the principle when it's applied to this type of machine. So I've taken the basic concept and I've reworked it. Well, we shall see how it comes out later on. Now, at the end of this video, I will give you links to his video that he sent me and the design that he sent me. And you can make the choice. You can use his design or you can use this design. This design will obviously appear on the Thinklaser website. So the choice will be yours. No, you won't be particularly interested in watching the machine cutting pieces. You won't even be particularly interested in some of the design principles that I've used here. But I will go through the quick basics of it when we come to finish the job and use it. So let's just cut the chat and get on with it. Okay, now we've got some 6mm material, and to be honest, as you can see, it's a little bit too big for the machine. I could hang it out underneath the door, but often with a job like this I tend to cut the sheet off using the machine. How do I do that? Well, it's very simple. The first thing I'm going to do is to load my program in, and then I'm going to set my origin up this corner here, which you can't see, approximately on towards the edge of the sheet. Okay, now I'm going to press the origin button, and I'm going to do, first of all, I'm going to get a pen, a marker pen, and then I'm going to do a frame. Okay, so about there is the size of material that I want. So what I can now do is to slide the material into the machine as far as it will go, so that it's nice and stable. We need to set the focal distance up. For this particular lens, it's 5.5mm. So I shall just set the height of the nozzle to suit. Now, I don't know at what speed I want to cut this, but it isn't particularly important. I think I'm probably going to be easily able to cut this at probably 6 or 7mm a second. So let's just go to the speed. Oh, will we here? We can set it up to 7. The power is full power at 78. So I'll now drive my head fully to the left. We've got the extraction on. We've got air assist on. So I just hold the pulse button down and the left hand arrow. Yeah, the beam is not dragging, so that's not bad. And it will make it to the end of the cut nearly, not quite. Let go. Right. So, there's my cut, and it has cut through, look. And all I've got to do now is a simple and it just breaks off at the end. So there's my piece of material to use in the machine. Now it is just slightly too big to sit on the table, but what I'm going to do is to just raise the table enough to support it. So now we need to set the speed back up, otherwise it will be annoying when we come to use the machine. Speed 117, that'll do. Enter. Okay. So now it moves around at a reasonable speed. Just check that the setting for the focus is correct again. 5.5 millimeters, 5.5. Done. Now, although I did my trimming off at 7 millimeters a second, I've actually got this set to 5 millimeters a second. Well, we're just about coming to the end of our 6 millimeter cuts. We're just making some little spaces here. Now, I've purposely designed these spaces quite a long way apart from each other because, as you see, when they drop, there's no guarantee they're going to drop straight down. And I certainly don't want the next spacer to overlap with its cut and damage it. But that one fell out a long way out of position. But it was well clear of this next one. Now, as you can see, there's a useful piece of material left on the end here, which if we try and save it, we've got to save all the other bits at the end there as well. It's a bit bulky. So what we need to do is really just be a bit prudent with our material usage and save this nice piece of material here for another application. And what I'm going to do this time, rather than do a complete cut, I've got the speed set to about 112 millimeters a second. So I'm going to go across, rather than cut the whole of the job all the way across, what I'm going to do is just go across at this high speed with the pulse and go and back again. Now basically what I've done there is I've scored the job. And what I can now do is just break it off and we can throw this piece away. Now, as often mentioned to you, I love using the solid steel table because A, it makes housekeeping so much easier, and with a little bit of this stuff you can take all the stickiness off the table. Try and do that with a honeycomb table. We're cutting this 3 millimeter acrylic at about 15 millimeters a second. I've got full power on, which is about 60 watts. And I have actually got full air assist on this particular thing because I'm not interested in the quality of the edge particularly. I just want it to be a nice size and a nice clean cut. And as you can see, it drops out wonderfully well. And you'll note again that I've got this standing on a solid base plate and I've got it standing on little standoffs there to keep it away from the back plate. When we take a look at that, the way in which the backing has shrunk away, that tells me that I've got just a little bit too much power on there, or I could go faster with the cut, because that's a reflection of power off of this back surface. It's not doing any damage to the product, but it just tells me that I could run a little bit faster. Now, as you can see, this material here that I've got is basically a frosted material. I can't be choosy about the acrylic that I get, because I get it for free, and it could be any finish, any colour, and it can be any thickness. But hey, beggars can't be choosers. I just collect it by the bucketful and use it. Okay, well, we've got all our 3mm pieces and all our 6mm pieces here ready to start the assembly. Now, to do that, I shall need some of this cement here, and this is from a company called Bondrite, not to be confused with an American company called Bonderite. Now, sadly, this company Bondrite is only in the UK, but what I'm using here is a PETG weld cement, which is capable of bonding acrylic as well as PETG. I'm told that it takes just a little bit longer to bond acrylic, but it's less likely to craze it. So normally with extruded acrylic, crazing is very evident, and with cast acrylic, it's less so. So anyway, we've got our material, and I've dispensed a small amount of it into this little bottle here. Now, I've only got about 1/4 of an inch in the bottom of the bottle, but that's probably enough to do all of this job. So you can see a little cement goes a long way, because it is basically just like water. Excuse me while I just top up with rocket fuel. Well, off we go then. Now, the other thing that we're going to need is a piece of kitchen roll. This is 2 or 3 pieces, 2 or 3 thicknesses of kitchen roll, because this very thin, watery cement passes right through sometimes, and the excess needs to be soaked up. But if you leave it standing still, it will stick to the paper. So I'll show you what we're going to do. Now, the important thing here is to make sure we choose the right pieces that go together. And we're going to start off with this piece here, which has got the big square hole in it, and we're going to look at this piece here. Now, it only fits in one way, because if you fit it in the other way, you'll find that the holes don't line up with the edge of the material. So only literally just fits in one way, like that. And that now gives us the opportunity to fit these in. Now, if you look at these, you'll see that they're actually bent. Something about the stress when they're cut out of the sheet has been released, and they're bent. But they've purposely been made opposite hand to each other, so that the bends go opposite ways. So what we're going to do, we're going to put them so that the inside edges touch. In other words, the bananas touch in the middle, and it's the outside ends which sweep out. Okay, now we're going to drop that. We'll keep them as a pair the right way around. So we're going to drop that one in this side here, like this. And we're going to drop this one in this side. You'll see that the arms are actually splaying out. Well, we should take care of that when we put the other end on. So we do this end first. Basically, it's all held together. So I'm going to put glue along probably half this edge and this corner and down there. So I'm going to do a little bit along here, and down there. Okay, now I'm going to hold that together and upright for about something like a minute to 2 minutes. Now, bear in mind what I said. We now need to move it around on the paper, and if you look carefully, you'll see where the glue has soaked into the paper. Now, it will very quickly dry off because it evaporates extremely quickly, right? But just to make sure that the paper doesn't stick to the bottom, we'll just move it around occasionally. Now, I've purposely made this piece so you can't put it in the wrong end. It's got to go, this big slot has got to go against all of these holes here. Now before I work on the other end, I'm going to leave that for 2 or 3 minutes to let it dry, because although it's basically tacked together and held together at the moment, it's not solid. And then what we're going to do, we'll concentrate on another part. Now these parts here and these parts here go together in a very obvious way. They just clip through there like that. Okay, now the problem with this is we've got to make sure that the pieces underneath here are the correct distance apart. And then we've got a little couple of assembly jigs for each one of them. So these basically sit underneath like that, and they're just temporary, just to hold the rails apart to the correct distance while we're gluing them together. So we'll just sit them on there like that, and what we'll try and do is we'll just tack these together with a little teeny weeny bit of glue at each one of these joints. Let's make sure we don't swamp it. And as you can see, we haven't got very many pieces left. It's a very simple assembly. We'll just move those out of the way and let them dry on their little assembly jigs. And now by this time, this should be strong enough for us to work on the other end. We've got to put this end plate on. So we'll plug the end plate on. Then we'll lift the whole thing up and drop it onto this plate underneath here, like that. So I should now be able to do the same thing on here. We'll tack this together, and run along here, along here. In fact, we'll see if we can do it all together in one go this time. Again, we'll just leave that to harden off for a few moments before we finish off doing anything with that. And we can probably now put some glue along the underneath side of these. And there we go, look. If I can show you that, can you see the cracking that's taking place on those surfaces there? The micro cracks. It happens on some surfaces, but not all of them. There's a little bit of cracking on that one, but virtually nothing on that one. So it's a bit random, and these little pieces here are now surplus to requirements. So whatever you do, don't try and glue those onto anything. So that's all the basic 6mm assembly done, with one minor exception, and that is these pieces here. Now if we take a look at these, you'll see that these arms are bent as well, and so consequently what I've done, I've made some stiffening pieces, and at the same time I've covered them in a little bit of glory for myself and for Caesar. And basically what they're doing, they're holding the arms straight. I can see the glue running in the joint underneath. Okay, well before we solidify this off, we'll just let that settle down and we'll build the other 3mm pieces. Well, to complete the basic frame assembly, we've just got these last few parts to assemble in 3mm acrylic. Now, to do this, I'd probably use something that I like to help me with gluing sometimes, and that is my collection of rubber bands. These holes have to line up with these holes on here, so there is really only one way for it to go together. So if we pop that in first, so that clips together like that, and here's where my rubber band comes in handy, because just at this point here where I want to hold it all together, I can put my rubber band there, and it now holds it all together. We've still got lots left in there. I'll just run along that joint there, and that joint there, and then I'll turn it over to the back, and I'll run along that joint there. And that's really a nice solid assembly now. Just keep it moving around just in case. But while we're waiting for that to dry, we can go back to the main assembly and we can look at adding some more glue to that assembly. By which time this should be sufficiently solid for me to take the rubber band off. and that fits in there. But at the moment, if I leave it like that, it will only slide along that middle section there. So what I'm going to do is to put it at this end section here, and then what we're going to do, we're going to put these runners on so that it stays at that height all the way along. I'm going to have to be careful because I don't want the glue to run down and stick to this bottom track here. So what I'm going to do is very carefully put a little blob of glue on this top corner, like that. Just let it run down a little bit and start to dry off, and then we'll clip it on like that, and we'll hold it solidly. Okay, that's got that stuck to that side. I'll do the same on this side. After about a minute or so, we should be able to take it out. We should be able to pop a little bit of glue just in these front corners here at the moment. Just there. And now that they're solid, we should be able to go along and do all the others. You can see the glue running up under the surface there. Okay, so now with a bit of luck, when we drop that into here, it should run smoothly all the way from end to end. As I mentioned earlier, I haven't bothered to show you everything that I've been cutting. I've got some 2mm material here, acrylic, which I've cut into these little discs with 3mm holes in. I've also got a 2mm thick, let's call it a packing piece, which has got a strange shape in it. And I've also got a piece of 5mm thick material, which has got the same strange shape in it. Now, this is particularly delicate, and it's also just a little bit flexible. And these little reliefs around the outside allow the bearing to just slip in nicely, and the bearing just snugly pushes in there, like that. Now that basically is a wheel. The original design that Caesar created was based upon using rollerblade wheels, which are almost 3 inches diameter. And 3 inches diameter is about that size. Well, as you can see, I'm making my wheels substantially smaller. So I've got a bearing here which costs about £1. I've got 2 O-rings here which cost a few pennies each, provided I buy them sort of 20 to 50 at a time. And it's cheaper to probably buy 50 and throw the rest away than it is to buy them in 2s and 4s as you can on eBay. So we don't need just 2, we need 2 per wheel, and we're going to make 6 wheels. We've got some M3 by 12mm long screws here, and we can put one of those, or in fact sensibly probably put 2 of them through a flange like that, and then we can drop the bearing on top, okay, and then we can put our packing plate on. Now the packing plate has still got the plastic film on, because basically it's so thin and flimsy I was frightened to take the plastic film off of it. Okay, and then we put the top flange on, then we can put our nuts on, and now we've got 2 O-rings, and our 2 O-rings will fit snugly on there and sit neatly between the flanges. So we've made 6 wheels. Well, we're starting off on another day now, and I'm sorry I've got a little bit of a croaky voice, but I've woken up this morning with a bit of a cold. But the main thing that I wanted to show you was that last night when I assembled the wheels on this unit, I noticed that things were not quite as perfect as I'd dreamed of. These bearings in here, they're not the most expensive bearings in the world, but if you take a look you can see that they've got a little bit of wobble on them. That one's not quite as bad. But basically they're very cheap bearings at £1 each. Their function is a rolling function, which is what I normally use them for, and they serve that purpose wonderfully well. If I apply any sort of load in this direction, the last thing I really want is movement like that. And so what I've done, I've looked at the problem in a different way. Here's the one bearing. I'm just putting a small amount of load on it to show you the twist. So in here we've got 2 bearings which are stacked against each other to reduce the risk of twist. And that seems to work extremely well. So I didn't have enough bearings to double up all the way round, so I ordered some last night and they should be here in the post today. Well, the bearings I ordered from RS Components have arrived, and we'll get on and do some building. Now, I've already pre-built some of the wheels, but I'll show you how I go about building this last one. Okay, so I've got basically the same shaped pieces as I had before, with a couple of exceptions. Instead of a piece of 4mm thick spacer in the middle there, what I've now got is 3 pieces of 3mm. I've searched through my stock, and as I mentioned to you before, 3mm acrylic comes in quite a large variation in tolerances. Now, I've tried to use something that's around about 3.2mm thick, so that basically 3 of these pieces make up the same as 2 bearings, 10mm. But it's not crucial if you're only using 3mm stock. Now, in addition to making these pieces look approximately the same, there's a slight difference. There are 2 of them that have got 1 outside diameter, and this third one which has got a slightly bigger outside diameter. So if I put a piece of paper behind it, you probably can see that the middle section has slightly larger diameter than the 2 side sections. And there's a good reason for that, which I will explain in a minute. But you need to understand that because you need to assemble them the right way round. Right, so first of all, we've assembled one of the outside rings, one of the smaller rings. We push that right down flat against the flange. Then we'll drop a bearing. Now sit the bearing on top there and keep it as flat as possible, and then gently apply pressure to it and it should pop in. Now we're going to put the centre slightly larger diameter ring on, and that should push over the bearing as well. Then we're going to drop the next bearing in, and then finally we're going to put the little outer ring on, which is, or the top ring, which is the smaller of the rings, and we push that down carefully, and so that that slides over the bearing, and the bearing should sit more or less flush with the top surface when we've got it fully assembled. Then we can drop the flange on, and now we've got 3 M3 nuts to hold it all together like that. Just tighten them up gently, not too tight. Just till you can feel some pressure come on. Now finally, we've got to put the O-rings on, so we can slip the O-rings just on like that. And the O-rings will naturally sit on the smaller section, not the centre section. Like that. Okay, now there have been basically 2 assemblies that we're going to make. We're going to make one set of static wheels, a pair of static wheels, which will be based around using a panhead screw, which is M5 by 25mm long. And just to make it neat, we'll put the head in from the headed side of the screws, and then we'll put an M5 nut on the back. And we'll just tighten that up to make sure that it holds the 2 bearings snug and pulled together. When we put it in here, these little nuts on the back here are likely to hit this face. So what we need to do is just to space that out with a couple of M5 washers, just to sit it clear of the surface. Then we should need an M5 nut on the back there, just to hold that wheel nicely in place. And that's a nice solid fix now. No flex or movement in that. On this other end here, we've got a panhead screw again, which is 40mm long. And again, what we've done, we've held the bearings together with an M5 nut, and then we've got 3 of our spacers that we made out of Perspex, and we slip that in there. Then we've got an M5 wing nut. So now we've got a nice freewheeling trolley, where the wheels on this end are at adjustable centres and the wheels at this end are fixed. Now here we've got a pair of loose wheels that are adjustable. So we're going to use an M5 by 40 long screw where we'll lock the bearings together. Then we'll put 3 of our spacer washers on. We'll slip this one in the same position as that one, which is number 3 hole away from the middle. And this slot here that I'm just putting my finger through is somewhere where we can mount what I like to call a live end stop. Now a fixed end stop would probably drag on the component that we're trying to engrave, and I don't want that to happen. I need it to roll freely. So what I've got here is a very small ball bearing. I'm fixing the ball bearing on with a countersunk screw, and underneath the ball bearing we've got an M3 washer, and that all fits onto this little bracket that I have made and cemented together. The ball bearing can sit on the top if you really need it to, but it means you sacrifice some adjustment, but it's designed to basically fit underneath. And there we go, so that's the assembly. We've got the washer underneath, the bearing and the screw, and then we can just lightly tighten up the whole assembly. Before I put all of this together, I tapped an M4 hole in there. There is enough thread there if you want to put a nut on there instead of tapping the hole. That's entirely up to you if you want to make the hole a little bit bigger. You can either put it on this side, which at times you may find handy to do, but the design is originally to go on the back side. So you twist it to put it in, then we put the screw head on this side, and on the back we shall have a washer and an M4 wing nut. Now there are times when this wing nut will actually clash with this little piece that sticks out here. It's not really a big issue because you can find a position for the wing nut where it's just tight enough that you can slide this up and down and it won't move. Right? So that's one possibility. You might even have a spring washer that you can put underneath there to achieve the same result, but that's entirely up to you. The point is that what we've got here now is an end stop, which when you look at it from above is a little ball bearing. Okay, now there are a series of slots in here which rise up 3 millimeters for every slot. Now, sometimes you may possibly find that that stepping is too coarse and that you maybe need only a 1 millimeter step or a 2 millimeter step. Well, if that is the case, you'll find that there are 3 of these plates. One of them's marked up at 0, one of them's marked up at +1, and the other one's marked up at +2. So number 2 will actually raise it up by 2 millimeters. If you want to raise it up by 3 millimeters, you put the 0 back on and you move to the second slot. So that means you've got increments of 1 millimeter right up and down this range. Okay, well it's about time, I should think, that I tried to explain how this whole thing works. Well, I'm going to demonstrate the simplest application for it at the moment, which is using just an ordinary cardboard tube. Okay, this is just a simple application to demonstrate the principle. Now, in this first position here, the wheels are the same height as each other. So you'll see that these wheels more or less, although these are the controlling wheels at this end, these wheels here are just about touching the ground. So they're basically parallel with each other. Okay, well the next thing to do is to drop our item in there and set the end stop, this thing here on the end. We'll set that to an appropriate height so that it rubs on the bottom, so the bottom of the job rolls against it. And then we do the same on the other end basically. What we can do, we can slide this forward and we can set the other end up so that that live stock also rests on the end of the job. That means that this job is not allowed to float either way now. Okay, so here you are standing in front of the machine. And what we've got, the original design of this was for these pieces here, down the side, to be further forward. So that in fact this edge here was touching on the cross axis, the beam of the machine. And as the machine comes forward in its y-axis, what it does, it pushes this carriage forward like this. Now at the same time as the carriage is coming forward, the head is sliding backwards and forwards this way. So the head is always in relation to these arms because these arms are fixed or pushed by the gantry. So the head always stays in this central position here. But the essence of it is that the gantry is pushing these arms forward. And as it inches forward, you can see what it's doing. It's causing this to rotate. Now, just in case you're having trouble imagining how this thing works, let me do this for you. Look, I've got two marks on here, and I'll put that up against that wheel there with the screw on the mark. Now we'll roll this forward so that the wheel goes forward one revolution. And there we go, look, one revolution, and we've reached that mark there. Now, that's because that happens to be the circumference of this wheel. If I put this on here, okay, and now we'll rotate the wheel one revolution there, and I'll put another mark on there at the top, approximately. If I put that mark on there, when we get round to here, look, that mark is on there. So it's direct one-to-one ratio. The same amount of motion on here has happened down on the table. And that one-to-one ratio remains the same. Even when I put something like this on here, which is much bigger, it's still transmitting the same amount of distance on the table to the object that's on it. It'll do exactly the same thing. There'll be 2 inches of circumferential movement on there for 2 inches of circumferential movement on there, because they're linked together by these circumferential drive wheels. So it's so elegantly simple that, as I said, I'm really envious of the design. Well, having built the unit and described the principle of how it works, I think we'll stop at that point because we're running out of time. In the next session, we've got a variety of all sorts of things here, anything down to a pencil. I don't think we can quite get down to cocktail sticks, but we can get as low as a pencil and all these various size cylinders. Then we've got the challenge of all these different shapes. This one is particularly difficult because it's quite a large taper and it's very strangely balanced. This one should be easy. This one is a rather interesting challenge, but now you'll see why I left that groove between the O-rings. So thank you very much for your time today, and I will see you in the next session.